transformations, I expect the parent function. So when you do your parent function, it's a minimum of 3 exact points. So we know 0 squared is 0. 1 squared is 1. 2 squared is 4. -1, 1, -2, 4. You can do more points if you'd like. So that's our parent function. Make that one dash, just like we did in the past. And what's our transformation this time? So just like we were doing on our last test. Move every point right and down. And then domain and range. What's the domain of this? And the range?
-1.
Are we okay with graphing if transformations are an option? We should be. You guys had that on your test and we did fine with it then. So with this, we need to talk about extreme points. This point down here is the vertex of my graph. And that is the lowest point on the entire graph. It's sometimes called an extreme point because it's the lowest. If my parabola is upside down, we don't get a lowest point, we have a highest point. So those highest and lowest points are your extreme points, the maximums and minimums. When we're talking about a parabola, it is the vertex. Okay, we'll use the terminology extreme points for other graphs, but right now we're focusing on parabolas. So if I ask for the extreme point, I'm asking you to tell me where the vertex is. It's our highest or lowest point. Okay, so identify the extreme points on the previous example and identify each as a maximum or a minimum. So if we look back at our notes from yesterday, okay, you guys look back at graph A that we did. What was that, a maximum or a minimum? A minimum, because we had a graph opening up. What was the ordered pair of the vertex?
-1, -2, -7.
Was it? -2, -8. You guys are looking at graph A from yesterday. That lowest point, our vertex, was -2, -8. On graph B, okay, that one was upside down, so did it have a maximum or a minimum? Maximum. Where was it? What was the vertex? 0, 0. You guys know where I'm getting these? Looking at those graphs we drew yesterday. C, the one we just drew. If I look at this one, we can see it had a maximum or a minimum. Minimum. What is this point? 3, -1. Okay, so we can find those maximums and minimums from the graph, but sometimes, if that's the only thing I care about, I don't necessarily want to go through the entire process of graphing. So we'll talk about the shortcut, how we can find those. If we are just looking for the vertex of a quadratic equation, we are going to use the formula x equals opposite of b over 2a. We'll use that to find x, and then we will plug x in to get y. Because a vertex is an ordered pair, so you have to have an x and a y. Axis of symmetry is the vertical line going through it, so it is just the x equals opposite of b over 2a. We'll write that as an equation. And how do we find a y-intercept of anything? Just like we did with lines. How do we find that y-intercept?
Put the x and the y equals 0.
Which, if I want the y-intercept, which one's 0? Mhm. So we'll plug in a 0 for our x's and solve. So that would allow us to get the graph. If we can find the vertex, if we can draw the axis of symmetry, and then find the y-intercept, then we can draw our full graph. So let's try that. So this type of problem is written where I cannot just do transformations. But we can get the vertex. A vertex is an ordered pair. So to find it, we do x equals the opposite of b over 2a. b is the coefficient of x, so that would be a -2, over 2a is the coefficient of x squared. Remember from that formula we wrote down yesterday, f of x is ax squared plus bx plus c. So we get -2 over 2 or -1. Okay, vertex is an ordered pair. I have my x. How do we get y? Put a -1 into our equation. So I get 1 minus 2 minus 5, which is -6. So my vertex is at -1, -6. Can you tell me, is that a maximum or a minimum on this graph? Minimum. Because it's a positive x squared, so we know our parabola is opening up. So that is our lowest point. Okay, the axis of symmetry. It's a line, so you have to give me the equation of a line. It's just x equals the x value of the vertex. And we draw that as a dashed line. So that's just the line of symmetry. That means on both sides of this line, the graph looks the same. And then if we find the y-intercept, that's when we plug in 0 for all of our x's. And we get -5. How many points do I require for a graph? 3. I have 2. But this graph is the same on both sides of the axis of symmetry. So if I think about my y-intercept, we can reflect it across the axis of symmetry. It's 1 away, so if we go 1 way the other direction, we have another point. Or could you plug something into your equation if you really needed to get a third point? Absolutely. So I'm going to check for at least 3 points. I want the vertex plotted, your y-intercept plotted, and I want you to draw in that axis of symmetry. Any questions there? What's the domain? Every time. What's my range?
From 6.
6 to infinity. All right, let's do that to graph another one. So, first I want my vertex. To find a vertex, we do x equals the opposite of b. So the opposite of -6 is +6 over 2 times a. So I get 1. Plug that in. minus 6 plus 7, which is 4. The vertex is an ordered pair, so you have to write the xy 1, 4.
So, the one, the X is the vertex also.
It's part of the vertex. Because a vertex is an ordered pair, so you have to find the x and the y.
So the opposite of,
Opposite of b over 2a.
is finding the X of the vertex,
Mhm.
and then the next equation finds the Y.
So once you know x, you can plug it into the equation to get your y. Axis of symmetry, that's a line, so you have to write an equation on a line. It's a vertical line going through the vertex, so x equals the x value of the vertex, which is 1. Let me draw that as a dashed line. And then y-intercept, you put in 0 for all of your x's. We get out 7. So I hit the y-axis at 7. Okay, we need a third point. My y-intercept is 1 away from the axis of symmetry, so if you reflect it, it goes 1 away the other direction. And then we have our graph. What is the domain? Every time. What is our range? Doing okay so far? Okay, one more. Can you guys tell me, does this parabola open up or down?
Yeah.
Down. So does it have a maximum or a minimum? Maximum. Okay. So to find our vertex, x equals the opposite of b, so that would be -8 over 2 times a, which is -2. Okay. Plug that back in to get our y. And you're welcome to use a calculator on this, I don't care. -8 plus 16 minus 3, so 5. So the vertex is the point, 2, 5. Alright, axis of symmetry is a vertical line going through the vertex, so what would it be? X equals 2. Let me just draw that as a dash line. Okay, how do we find a y-intercept? -3, so we hit the y-axis at -3. So for our graph, we need 3 points. I have 2, but if I look, my y-intercept is currently 2 away from the axis of symmetry. So if I reflect it, it would go to the opposite direction. Flipping that point over the axis of symmetry, and then we have our 3. Not great here. Domain. Range. So, if it's written in the vertex form, like the first problem we did today, it would probably be easiest to graph it first and then look at that graph to tell me like the vertex and things. But if it's not, then we use our equation to find our vertex and work it out from there. Do we have questions about this? So without graphing, I want you to answer a few questions. I want vertex, axis of symmetry, and if it opens up or down. So how would I find the vertex? Opposite of B over 2A. So that gives me a 1. And to get the full vertex, we have to put that back in. So we have -3 plus 6 plus 1, which is 4. So the vertex is the order pair 1, 4. Axis of symmetry is x equals the x value of the vertex, so x equals 1. Okay, can you tell me if this opens up or down? Down. So I didn't ask this, but does it have a maximum or a minimum point? Max. Okay, I'm going to change B from what I have on here. Let's say, instead of this equation, I gave you 2 times x minus 5 squared plus 3. Okay. If I'm asking for the vertex, if it's written like this, can I just do the opposite of B over 2A? No. Let's think about our parabolas though. Okay, so we know what a normal parabola looks like. We think about our graph from previous tests. We know it looks like this. What will this minus 5 do to my graph? And the plus 3? I'm not even caring about this 2 right now, because all I'm trying to do is find the vertex. My vertex was 0, 0, but if I move that right 5 and up 3, where does my vertex end up? Positive 5 and up 3. So if it's transformations, you can just think about how the vertex gets moved. Axis of symmetry. And we have to write it as? Okay. Does this open up or down? Up, so does it have a maximum or a minimum? I want you guys to do C.
Do we normally put the minimum, or is that just for fun right now?
Yeah, just right now. I might ask you that question at any point, but. So to find our vertex, this one we have to go back and do the opposite of B. So the opposite of -4 is +4 over 2 times -8. So we get 4 over -16 or -1/4. We don't have to have all nice numbers, so this is fine. So then we plug that in. So we get -19 halves. Is that what you guys got?
10.5.
Because this is -1/4 squared is positive 1/16 times -1/8 is -1/2 plus 1 minus 10.
That's what I did. I did it wrong. I put positive 1.
Oh, okay. So my vertex is -1/4, -19 halves.
Yeah, I did it on the calculator, I feel it too.
Axis of symmetry, what would I write? X equals -1/4. If you just tell me -1/4, that's wrong. It's a line, so you have to have the x equals. What else did I ask on these? Does it open up or down? Down. So does it have a maximum or a minimum? What if I said, what is the maximum value? So if I ask for the what is, the max or the min, that's just your highest or lowest y value. So you don't give me the full order pair, it's just the y itself. Alright, are we having any issues with this stuff?
Normally, do you want us to write it in decimal, because decimals are easier to
Grab something that's 19 half.
As long as it's exact, I don't care. So if it's like 1/3, I don't want you to tell me 0.3, I want you to tell me the 1/3. But 1/2 and 0.5 are equivalent, so it doesn't matter. Alright, I am stopping here for today. So there is a Math Excel assignment open that's due tomorrow. Tomorrow we're going to finish the last piece and there will be a different